How you doing? My name is Emmanuel Deleon. I work with the CSU Agricultural Water Quality Program. Our mission is to implement targeted best management practices that can improve and reduce nutrient and sediment loading in our water bodies. We evaluate best management practices by quantifying the amount of sediment and nutrient abatement that best management practice can have. So we do that by installing first a water measuring device such as this H-flume, and by sampling hourly samples with a Telodyne Avalanche or a Teledyne ISCO, which is our industry standard water sampler. Some of these best management practices that we evaluate are conservation tillage, placement and timing of that fertilizer, as well as filter strips, to name a few. In addition, we also got a CIG grant, which stands for the Conservation Innovation Grant, which will allow us to build our own low-cost water sampler and do a side-by-side test compared to our industry standard that costs close to $10,000, while our low-cost sampler roughly costs about $700 and has very similar functionalities. Let's go ahead and take a look at some of our installations. So here we have a H-flume with an approach that allows us to accurately measure total volume or discharge of your field. This essentially converts height of water to a flow rate by using an equation that is attached to whatever flow device you have. We essentially have a 1.5 foot H-flume. This is also attached to our low-cost water sampler and our industry standards, so we could essentially do a side-by-side test, allowing us to capture a runoff at the same time, at the same volume, and then we could do a side-by-side comparison test. This system is attached to our industry standard, our Telodyne Avalanche. This is a Teledyne Avalanche water sampler. This is a refrigerated model that essentially is considered the industry standard for edge-of-field water quality monitoring. It allows us to do time sampling as well as flow-weighted sampling. It's automated, so once a certain level of water is detected by our bubbler unit, it automatically starts sampling however you program it to do. You could also attach rain gauges, pH meters, and other sorts of devices to act as triggers, so you could start sampling whenever some type of situation changes. Here we have our low-cost water sampler. Up here is the brain of the operation. It holds all the electronics. We used a particle boron with this is a cellular microprocessor, a step peristaltic pump with a step motor controller, and it's all powered by a 12-volt battery that's hooked up to solar panels. This project was funded by IIC with matching funds from Western Sugar.